Item B, intrinsic geometry, exterior algebra. In 3D, could be 2, 3, 4, D is the dimension, okay, of the manifold. Now, B part 2, manifold, push forward and pull back. B part 2, lecture 3, important property of the tangent vector capital X, P. Okay, the tangent vector at point P, which belongs to the manifold. Now, give the manifold here. This is a tangent vector P acting at P. This is for 3 dimensions, for instance. This is the curve belongs to M3. This is the fantasy, the natural coordinates. You see, this is natural coordinates. Attention now, point Q coincides with point P. That's a very, very important issue. This is invariant. You see, this I just, you see that this is a point, okay? This here is the same, this point Q, the same point P, as I emphasized before. It's written over here. So the coordinates or functions x1, x2, x3, this is the coordinate of point Q. This is invariant. Point Q, point P is invariant, which does not depend on the coordinate system. Now, the tangent vector xp acting on a scale, on a vector, doesn't matter, is xi partial respect to xi. Attention now. Xi, small xi, they are the coordinates. You see, they are the coordinates. Capital X is a vector, okay, related to this coordinate over here. Xi is contravariant components. This is the covariant basis, okay, of the vector. Both here belongs to the vector space. You see, you just look at here and look at there. Now comes to the important property. From the lecture, the previous lecture 2, xp acting on this coordinate xj, the function. This is xi partial of xj with respect to xi. From the previous lecture, we obtain this over here, which I cannot obtain because this belongs to the manifold. This is related to the fantasy, to the natural coordinates, like that. That was derived in the previous lecture. Now, this xi delta ij, this is xj. Attention now, xp is a map. This is a very important property of the tangent vector in which it is a map. This is a map acting on xj leads to capital Xj. These are the components, the contravariant components of the vector x, x at P. This is a tangent vector, okay? And these are the contravariant components. Now, just recall that there's a space vector. This is the basis, okay, of this space vector, the vector space. These are the components of the vector, okay? Components, contravariant component. This is a covariant basis. This is the dual, okay? dxi, they are the basis vector for the dual vector space, and x, in this case, xj, you see the lower index here, this belongs to the dual, the cotangent vector space. Don't forget that. This is cotangent vector space. You see? This is a tangent vector space, this is cotangent vector space. V V here, capital V is a vector space. The V asterisk is the dual vector space or the covector. Okay, this I showed, okay, in previous videos. Okay, now just to recall that the inner product, attention here, there is no dot product when you talk about intrinsic geometry. This is here, this inner product. The inner product is delta ij. Now, attention now, that's a property. This inner product between the same bases is Gij. Covariant metric belongs to the vector space. This inner product is Gij, upper indices. Contravariant metric belongs to V, the dual vector space. And the property, Gij acts on the AI, okay, then it lowered the index to Ij. This Jij acting on AI, and this go to the J, the upper index. And this is the property of the conic delta. All this we derived in previous videos, previous lectures, see? That's it. That's a very important property, okay, of the tangent vector. It acts on these coordinates, okay, the local coordinates, and leads to the components of this vector x of p. These are the contravariant components. Okay, that's it.